Hi, my name is Christopher Clark, and this is my entry for the AES Student Design Competition. I'm currently a PhD student at the Singapore University of Technology and Design, and I specialize in electroacoustics and machine learning. I'm currently working on the conservation of sonic signatures for vintage recording and mixing equipment. As an audio designer myself, I often run into the problem of not being able to decide between two very similar circuits in my designs. I can give you an example of that right now. The example here shows a VCA compressor. On the left we have the VCA, and on the right we have the output transformer. And in between we have the role of a makeup gain amplifier, and we have these two line amps, circuit A and circuit B. And they sound very, very similar to each other. When you bring the gain up, you're trying to see whether you can hear a difference, and it's kind of on the cusp of whether you can actually perceive it or not. But perception is not in the scope of my application. I'm only wanting to consider the objective, measurable, empirical differences. So in this case, it would be hard to make a decision objectively. So how do we make a decision about these circuits? Since Rupert Nee's passing this year in February, I have been inspired to make this app called CircuitComparedre to also give my input for the audio design domain. I run through this app with an example. I have designed 3 very similar amplification circuits in software, that is. These 3 circuits use a very similar algorithm to each other, and they've been tweaked a little bit to give you different responses in different frequency regions. I want to use this app to then demonstrate to you how the results would come back and what these results mean in a meaningful way. So I'll start by loading up the 3 folders. As you can see, when you load the folder in, the red lamp turns green. This tells you that the application knows that there is a path to the folders for the circuits. For this demonstration, I will be comparing 3 circuits. I will now extract the features of these 3 circuits. As you can see, it tells you how many files you have, plus what the current file being analyzed is. Now that we are done performing the feature extraction, we can then train the model to perform the machine learning on our dataset. So it tells you which circuit is empty. I will go through the similarity index first and the highest E-score. Because training is done with cross-validation, there is multiple times where the model is trained with different sets of training data and then tested with different sets of testing data. And the highest E-score tells us the confidence level of the prediction of each class. So in this case, the circuit A, the model has the highest confidence level for that. The similarity index in this case refers to how similar the data is, and I'll show you that in the confusion matrix. So if we plot the confusion matrix, this over here shows us the true classes and the predicted classes on the bottom. So this gives us a view of how the data has been misclassified and how this similarity index has been represented. For a further look at the data, we can look at the THD. I implemented this because THD is a very common and sort of intuitive feature that we can all look at, and so we can plot it with the hold on and plot all 3 of these data sets. It's actually a 3D graph, so let me go ahead and spin that around. Over here we have THD in terms of dBc. On the x-axis it's the frequency, and on the y-axis is the input amplitude, which was generated from a set of amplification algorithms with slight non-linearities in them. Over here we can see that the THD below 7000 Hz is kind of the same, and that contributes to the similarity index. What's different about these circuits is that they have varying THDs above 7000 Hz, and that is what helps the machine learning model separate these 3 circuits. I will not be demonstrating the extended features, but it's the same thing except with the spectral descriptors of the MATLAB. I want to thank you for taking a look at my application, CircuitComparedre. Thank you very much.